So if you have a polynomial and there are no i's in that when you're looking at it originally, then if an imaginary number is a 0, the conjugate will be as well. So basically, if the original polynomial doesn't have any i's, your imaginary zeros come in pairs. If you have one, you're guaranteed to have another. The conjugate, the only thing you do is change the sign in the middle. So, first part of the homework tonight, you're going to have problems exactly like this. So, I am asking you to come up with the polynomial for this. And I'm telling you that -4 and 3 minus I are zeros. Now I want my polynomial to only have real coefficients, so there are no i's when I actually get my polynomial. If we look at this, -4, that's a real number. Do we have any rules about if we have one real number, 0, that there has to be another? No, that's not a thing. But if 3 minus I is a 0, if 3 minus I is a 0, what else has to be? 3 plus I. That's what we just said. That if you have one imaginary 0, the conjugate will also work. Okay, so this one will have to have 3 zeros. Then kind of like the last ones on your homework, you had the 0, you had to write the polynomial. Okay, so if -4 is a 0, what is my factor? If 3 minus I is a 0, you have to do x minus that whole thing. So it becomes x minus 3 plus I, because you would have to distribute the negative. And the other one would be x minus 3 minus I. Does everybody see where I got those? I just did x minus each of my zeros to get the factors. Now, if you multiply this all out, your i's would disappear and we would have the polynomial. But I never said we had to. We can leave it in factored form. The ones you were doing on your homework last night also had some conditions, like f of 1 equals 3, but did I say anything like that here? No, so you're done. This is all you have to do. So all I'm going to try to get you to do on these problems is recognize when there are other zeros that aren't given to you. Alright, so let's look at this one. If 2 plus I is a 0, what else has to be?
2 minus I.
If 3 is a 0, what else has to be? There isn't anything else, is there? Trick question. Okay. What if -I was the 0? What else would you have to have? Okay. So what would my factored form be?
X minus 2 minus I.
And does it matter what order you write those in?
No.
Alright. So there's the first, 5 problems on your homework. If I put a multiplicity on something, I said it was like 3 multiplicity 5, what would you do?
X minus 2.
Okay. If I put something with radicals, does that change anything? If I said 2 minus the square root of 3 was a 0, what else would I have to have in here?
2.
Do I have to have a second one? No, because it's not imaginary. What would I put for my factor? Okay. So we can handle that, right? Last thing I want to do then. So when we do the P's and Q's, that only tells us the real zeros. Back on section 3.2 when we did synthetic division, you guys had to do a synthetic division with an I, and we struggled a little bit. So I threw some more on here and thought we might practice that. So if 2I is a 0, if I give you the first 0, do we have to do P's and Q's? No, I'm giving you the starting point. So we start with synthetic. If I give you the 0, that's the number you put in the box. Put our coefficients, space these out a little bit. Leave yourself some space here. So 1 comes down. 1 times 2i is 2i. Negative 4 plus 2i. Can you add those? No. Okay, now we multiply. So you are doing 2i times the negative 4 plus 2i. So if you distribute, you get negative 8i. 2i times 2i is 4i squared, which is negative 4. So when you add, those cancel. We get negative 8i. So now 2i times negative 8i is negative 16i squared, which is positive 16. We add and we get 0. Now normally at this point we do box method, but can you do box method with all these i's in here? No. What could I do then? You could. It's going to get ugly, but you could do that.
If 2i is a 0, wouldn't negative 2i?
Yes. 2i is a 0, which means so is negative 2i. So if you have another zeros, couldn't we divide again? So we'll put the negative 2i here. And then I'll put my answer to this problem. So the 1, negative 4 plus 2i, and negative 8i. So 1 comes down. 1 times negative 2i is negative 2i. Add those, we get negative 4. Negative 4 times negative 2i is positive 8i. Add and we get 0. So we are left with x minus 4. My directions were to find all the remaining zeros. What would make x minus 4 equal 0? Positive 4. I gave you the 2i, so we don't have to list it again. And then the other one we figured out was negative 2i. Any questions on that one? Last example. Alright, so if I'm giving you the first 0, what do we do? So 3 minus 2i is what goes in the box. One comes down. 1 times 3 minus 2i is 3 minus 2i. Add like terms. Negative 9 plus 3 is negative 6 minus my 2i. So now we have to take the negative 6 minus 2i times 3 minus 2i. So if I FOIL, okay, 4i squared is plus negative 18. 12i minus 6i is positive 6i. So if we add like terms, 21 minus 22 is negative 1 plus 6i. So we FOIL again. Negative 3 plus 2i plus 18i minus 12i squared. So negative 12i squared is positive 12. Minus 3 is 9. 2i and 18i is 20i. So add and we get 30 plus 20i. And we're going to FOIL one more time. So that gives me 90 minus 60i plus 60i minus 40i squared. Negative 40i squared is positive 40 plus 90 is 130. 60i and negative 60i cancel. So that just gives me 0. What next? So we know that if this is a 0, so is the conjugate. When you do the conjugate, the only thing that changes is the sign in the middle. Now, the second one should always be pretty. All of these i's should disappear. So the last one we had to do quite a bit of work, but this should clean up a lot. So 1 comes down. 1 times 3 plus 2i is 3 plus 2i. Add those and we get negative 3. If I multiply, I have to distribute that negative 3, so we get negative 9 minus 6i. 6i's drop and we get negative 10. Distribute, so that's negative 30 minus 20i. Add, everything cancels and we get 0. So we are left with x squared minus 3x minus 10. And what could we do with that? Box method. That factors into x minus 5, x plus 2. So the question was, give me the remaining zeros. I gave you the first one. I gave you 3 minus 2i. You tell me all the others. So we knew 3 plus 2i. What makes x minus 5 equal 0? And x plus 2? Is this okay with everybody? Okay, so here's what we're going to do. You have quite a bit of time left. We are on day 3 of this homework. So 56 through 72, every other even, those are all ones where I gave you the zeros and you're just writing the polynomial. So keep in mind, check if there's any missing zeros. Then the last 4 are all practicing those p's and q's. You might get some imaginary zeros within that, but not necessarily. So you've got time to work on this right